All right, class, welcome back. Sorry, this is 3.4, the slope of a line. This is part 2. My last video got cut off again. So we're just going to start on right where we left off, which is with another example of a line, a graph that you're going to see, and you're going to be asked to identify the slope and the y-intercept. Okay, so the slope of this line, then I'm just going to start at some point on the line, any point on the line. Easiest is from one whole point to the next. I'm going to start right here and I'm going to say to get to the next point on the line for y, I'd have to go up 1. And then I'd have to go right 1, 2, 3, 4, 5, 6. Okay, so the slope then of this line, I'm going to go up 1 and right 6. Again, this line slants upward from left to right, has a positive slope. So my slope is 1/6. My y-intercept is the point right here where it crosses the y-axis, and that is the point 0, -1. So my slope is 1/6, my y-intercept is the point 0, -1. Now this isn't asking you to write the equation of the line, but I should be able to, again, using the y equals mx plus b. If I just substitute m, 1/6, and I substitute b, which is -1, this right here is the equation of this line. So here is the visual picture of all the solutions that I could put into this line. Okay, so that is identifying slope and y-intercept. The last couple of concepts we're going to talk about in this section, just checking to make sure I'm still recording, are going to be parallel and perpendicular lines. Okay, so parallel lines. Well, parallel lines look like this. They're lines that have, by definition, okay, parallel lines have the same slope but different y-intercepts. Okay, so by definition, parallel lines have the same slope but different y-intercepts. The reason why they have to have different y-intercepts is because if they had the same slope, so if I had a line and it has the same slope, so this is my first line and my second line, they have the same slope and the same y-intercept, you can see they're literally the same line. So in order for them to be parallel, they have to have a different y-intercept, otherwise they would be the same line. Okay, but again, note here that they have the same slope. Okay, this is the definition of a parallel line. Well, what about perpendicular lines? Well, what do those look like? Perpendicular lines, by definition, intersect one another. So we're talking about two different lines here, and they intersect one another at a 90-degree angle. So my x and y axis on my xy coordinate system, those are perpendicular lines. Again, these aren't just intersecting lines. They don't just cross at some point like, like this. They cross at exactly a 90-degree angle. And perpendicular lines, this line and this line, have what's called inverse reciprocal slopes. Okay, inverse reciprocal. Inverse means, you can think of inverse as the opposite sign. And reciprocal as, I'm going to flip it, whatever it is. Okay, so if I had an equation that said, let's say, 3x minus 5. Okay. So the inverse, so the slope right here, I'm going to just identify the slope. The slope of this line is 3. Okay, the slope of this line is 3, and the inverse of 3, the opposite of 3, is -3. So it's got inverse, but it's also reciprocal. Right now, it's over 1. I need to flip it to be 1/3. So this is the inverse reciprocal of 3. So it's going to be the opposite sign and flipped, inverse reciprocal. Okay, so if you were given Oh, my math lab says this in a really weird way. My math lab says this, that the product of the slopes is -1. Remember that product just means multiply. So looking at that example, if I had, for perpendicular, if I had a slope of 3 and I had a slope of a -1/3. So this is the slope of one line, and this is the slope of my second line. If I product, or take the product, multiply these together, 3 multiplied by a -1/3, straight across the top, straight across the bottom, I get -3/3, which is a -1. So the way that my math lab says this is they have a product of -1, which is great, totally true. But the way you want to think of it is it's inverse reciprocal. So how would you be asked a question about this? Well, you could be given a line, and it could say, hey, given this line, what is the slope of the line parallel to it? Well, parallel have the same slope, so the line parallel to this one would have a slope of -5. But what if I said, well, what's the slope of the line perpendicular to this one? Well, it's going to be the inverse, which is going to be positive, and it's going to be the reciprocal, which is going to be 1/5. Okay, again, inverse reciprocal. So given this line right here, if I wanted to know what the slope of the line parallel to it would be this. And given this line right here, if I wanted to know what the slope of the line perpendicular, it would be this. Okay, so then you might also be asked, you might be given two different lines. Let's say you're given okay, you're given these two lines. The question here will be, are these lines parallel, perpendicular, or neither? By the way, if it's not the same slope, okay, let me put it this way, if it is the same slope, then they're parallel. If it's inverse reciprocal, if these are inverse reciprocal slopes, then it's perpendicular. And if it's anything else, then these lines are not parallel or perpendicular. So let's go through and identify the slope of these lines. Well, this one's easy because it's in slope-intercept form. The slope of this line is 1/2. Great, but what is the slope of this line? Well, to get the slope of that line, I'm going to have to solve for y. So I'm going to subtract the 2x. I get -y is equal to a -2x plus 6. Divide everything by -1. And I'll write it up here. Y is equal to 2x minus 6. All right, so this is my second line. The slope of this line is 2. So the question is, are these lines right here, are they parallel? Well, are these the same slope? No, they're not. So they're not parallel. Are they inverse reciprocal? Well, they're reciprocal because this is 1/2 and this is 2/1, but they're not inverse. This would have to be a negative. So they're not inverse reciprocal. So that means they're not perpendicular either. That means these lines are neither. They're not going to be parallel and never cross, and they don't intersect at a 90-degree angle. So these are neither. Okay, so that is some of the questions and concepts from 3.4.